moving on to chapter 8. So chapter 8 is basically all on integration and integration techniques. So when they start 8.1, we looked at just different possibilities to integrate. So my goal here is just to kind of go through it, not do problems in this, just kind of a review of what we did. And you could hear from me on a video, at least, what to emphasize, that kind of thing. I didn't say that in the other video, but that's really the goal here, isn't to do problems and anything like that. You have plenty of extra problems posted with solutions on Canvas right now to look at. So let's just go through these. So 8.1, the first one we did, basically like how would you do that? And one thing you can do is complete the square. So if you complete the square, then you can see the format. You see that it's a squared minus x squared, and you know that basic form is an inverse sine. And then you just apply the formula from here to here. So it's setting it up in that form. So that's it's a good question, good possibility. Next one, multiply it out, and then you can look at each of the individual integrations, each of those individual integrations. Next one was long division. So all three of those isn't anything new really. It's just applying other techniques to do the integration. So long division. So I wouldn't test you on every little detail on like this one and this one and this one, but know some of those techniques. So if you see one that you want to do enough of these that you see that this is what we would call improper, like the fraction is improper, kind of, right? So then you can use long division to simplify it. Okay, next one. Again, just splitting up the fraction, and then you have the two different integrals, and then this first one is just u sub, and the second one is an application. And I think I probably had you do that in class, so I don't have all the solution there. Okay, and then this one was the one that's like, how would you think of that? Well, I don't know. It's kind of from practice and trying stuff. I could give you a hint, like, hey, multiply by something, and then you do that, and then it simplifies. So multiplying by 1, adding 0, where you're adding, subtracting the same thing, is a common technique in math to make things work how you want. Okay, so then I think that was it. We did more examples, but that was 8.1. Then we get into the kind of the new stuff. So in 8.2, integration by parts, very important integration technique to use. So all of this here. So know how to do it. You're going to get one of these, no question. There'll be a by parts one. Could look like that. I set out some guidelines. If you're good at doing a bunch of those guidelines, you can kind of see and understand. Or you just try it, see if it works. If it works, continue. If it simplifies it all the way. You can always try, switch them. You can switch what you choose here and here and see if it works. So the more you do them, the more you'll see kind of a pattern of which ones work, which ones don't. Okay, then the only other type to really talk about in this video is this one. This is the one where you start on one side, you end up seeing that you get a duplicate. So this here is the same as this. And so once you integrate that again, you see that you get the same thing. So this purple part is the same as this one. And so you essentially are solving for it. So when you solve for it, you get two of them, and you divide, and then you get what it's equal to. So you actually found an explicit formula without actually evaluating. And I should put plus C here. It's really, it's an indefinite, so it should be a plus C. You kind of did that after the fact, but yeah. All right, moving on. 8.3. Trig integrals, it's really reducing this form. There's what they call reduction formulas you can use, although I don't really want you to use those. I want you to apply these identities, these and other, all these identities, this one, this one, this one, this one, however you need to simplify, reduce the powers. So the whole goal really is to apply those trig identities to reduce these powers down to something that you can integrate. So substituting in where I highlighted here in green, multiplying out. So that's how I want you to do it. It won't be this exact one, but that's one of the techniques. Then we get into one more like this, where you have to factor or peel off some of those different powers so that when you pick u to be something, the du gives you the cosine dx. So that's what I'm highlighting here in pink. And so once you do that, you get it to simplify or disappear. So then you have everything in terms of u, and you end up with just a polynomial to integrate. So those are good. Both of those are good examples. So of course, so that one, and then you end up with the tangent and secant cases like this. So you'll get one of these, no question. And I want you to apply this technique. So just applying a reduction formula will not be acceptable. So make sure you can do these. So it'll be something similar to those for sure. 8.4 got onto trig substitution. There'll be definitely a trig sub. The key here is to know the three forms for those and the triangles, right? So all three of these triangles, here, here, and here, and their basic setup. You'll all be able to write all these down, look these up. So it's not like you have to memorize it, but you got to work with them enough to know what to do. Okay, so practice those. You're going to have a trig sub, and I'll probably tell you use trig sub because there's often another way to do it when you're doing those, but it's one of those that you need to know how to apply it and set it up. So look through our examples. It'll be one similar, to all those. This one required a little bit of extra, manipulation, discussion. Kind of like it because you can simplify it, right? You get just a constant, but a constant plus an arbitrary constant is an arbitrary constant. So this one was a good one. I like that one. All right. Then we moved on to 8.6. So tables. So tables can be tricky. This first example we did here was a bit tricky how to do it. So make sure you do a number of these. You got to practice these problems and how to set them up. So once you have made your correct substitutions, then you go directly to the substitution. So this is all a good example of that, and how to simplify it. Okay, and then the next one. So these are just examples we did. Nothing real other than how to do them. Trying to emphasize here. This is quite a messy formula, isn't it? Wow. Probably wouldn't give you such a large one on the exam, but make sure you can apply all this stuff. Okay, so nothing real specific. Just know how to use tables. And we've already done some of that. More like 38, where it's inverse trig, or we developed a formula to apply it. So we've done something similar. Then we got on to 8.8, improper integrals. And I think the takeaway on this one is the notation. It's important to apply the right notation, even though if you didn't necessarily use it, you'd get the right answer. That's not the point. The point is to apply what's appropriate and what makes sense. Because sometimes you can't, if you're trying to find the area here, and you went from -1 to infinity or something, you can't integrate across something that's undefined. Now there you would not get a correct answer, but but the point is it has to make sense. All right, so know those three cases of how to set it up. So this notation, basically infinity, really means this limit approaching infinity. As I stated also in class, do not use infinity like a number. So don't put infinity down and treat it like a number in any of your work. Okay, moving along. So did all those examples. Approach from the left, approach from the right, and then we did infinite discontinuities. So this is where you have t approach a constant on whatever side. So in this case, t is approaching on the left, and in this case, t is going this direction. So it is approaching on the right, so t is going this way. So t is approaching a on the right. So this would be a right here. Okay, so make sure that, so that's another one where, if you just plugged in that value and substitute in, you'd probably get a correct answer, but I will be looking for that limit, this format right here. I'll be looking for that. Okay, so practice a bunch of those, of course. The different cases we did. So this one integrates across a discontinuity at -1. So you got to break it up, right? And do your limits. This one you might have actually gotten a correct answer because these go to 0, I think. So this one goes to 0, this one goes to 0. So this would be really important to do the correct notation, even though you might get 9. I have to look at that closer, but. And then, we did the negative infinity to infinity. You got to break it up. If you can, if it works, break it up at 0 is always the nice indicator. This example, the area under the curve was pi, which I think is really cool, right? This one's pi, so this area here. So you're going from basically a rational function whose area is pi that has nothing to do with sines and cosines and stuff. So that was pretty neat. All right, then, this was just more examples. This was actually determining how the graph approached for tangent and tan inverse and how you interpret it. You'll have, I'll talk more about how the exam format's going to be, but you'll have access to all those formulas when you do it. I'll talk more about that later. Then I talked about Gabriel's horn, where you have 1 over x, and you rotate that, and you looked at the surface area around the outside versus the entire volume as you approach infinity. So this was just an application example of stuff we've done, including the infinite limits or infinite integration concepts. And in one case, you get a finite surface area, meaning it converges. And then, so the volume of that converges, but the surface area here, we showed that it diverges. So you have finite volume, but infinite surface area, which was kind of cool and strange result. Okay, when you get to your homework in 8.8, someone pointed out to me that I had assigned a test for convergence on after 34, and we didn't cover that. So don't worry about test for convergence. We will actually look at that, plenty of that, in chapter 10 in the sequences and series chapter. So just do the types of questions that we just did, that we just demonstrated up there, 1 through 34. This was the classwork we did. I don't have solutions to these, so don't, you try them if you'd like, but you don't worry about them. I would just go on to the ones I posted. I will not have time to do these integrals at this point. So, just move on, go do the ones I posted of that other book. The solutions are there too. The odd solutions are posted as well. So practice these problems. And we'll have more to discuss on Canvas later.